Okay, with 3 ultracaps here, and I have 2 diodes in place. So basically, the positive side, which is represented by this black wire, is each one of the on the breadboard. Each one of these rungs here has a plate that connects everything on that line. So that's the positive. Then we got the silicon diode right here, and then it's on the positive side, negative side, back to back to the LED, positive side, negative side. So I got them back to back right here. That's the positive side. It's the negative side of the diode. This is the positive side of the LED, negative side. And as you can see, this is cap 1. This is the negative side of cap 1 and the positive side of cap 2. So this is the negative side of cap 1. This is the positive side of cap 2. Okay, now I'm going to jump the second back-to-back diode, the silicon and the LED right here. This is going to be these two. I got the silicon and the LED back-to-back. So these are back-to-back. And on the negative side of the lighted LED, we're going to have the negative post of the second capacitor here, which is the back side, which is this wire here. So this wire is going to go in place on this rung, cathode side of the LED. Since I'm just using wire that I have, they're not color coded because I only have a little bit of the red wire. I'm just experimenting. I have more of the green wire. But for cap 2, when I connected the negative side on the negative side of that second LED, and for the third capacitor on the positive side on the back end, I'm also connecting it on the same run, as you can see, for the negative side of that LED, the cathode end. So you look on the chart, this is the second LED, which is right here, and this second LED is on the back end of the second capacitor and on the positive end of the third. And that's what we got right here. Okay, I went in and added, this is the back-to-back. We have the silicon diode, negative side and positive side of the LED, negative side, and the final connection to the negative side of the second capacitor. So what we have is we've got the 3 LEDs, and this is the third capacitor. So the negative side terminates at the LED right here. We're not going any further than this. And that's what we have right here. So each one represents the load from each cap. Now to make this a dual layer balancing circuit in case an LED fails, you want to add resistors here between each cap connection between negative and positive. These are you have to have the same rated resistor. I just pulled some out to show you how I'd wire these between each connector to the caps. This one, and that's the positive. This is the negative. So you got a resistor between the positive and negative of cap 1, cap 2, same thing. Positive, negative, right here. Then cap 3 with that resistor, and rated the same resistance. Electricity will travel to the least resistance. So these resistors we valued at probably about 350 ohms, 400 ohms, and the flow of current will flow through these diodes before it will flow through the resistors. So if you have an open circuit with the LED, they will flow through the resistors. Okay, I'm going to need to add about a little over 8 volts. There are 2.7 volts a cap, and these are in parallel, so each one of these will deliver around 2 volts to those LEDs as the caps fill up. And let's start adding a little bit of voltage to this. Okay, I'm at almost 7 volts. I can go up to a little over 8 on this set, but it's pretty much beginning to balance itself out. Turn the lights off here. If you can see that the third cap has more voltage than the other two, so it's absorbing more current in the form of light resistance. And anyway, that's how you wire a balancing circuit, hardwiring it on a breadboard.